Hi guys, welcome back to the channel. Jag here. In today's class, we're going to continue with our Science 10 content on optics. So with that, let's get started. So here we are, okay? What we're looking at today is going to be refraction, okay? So the term refraction here just means that the light or the ray of light is actually just bending, okay? So it's going from one medium to another. And this is just kind of like when you put a pencil, okay, into a beaker of water or a glass of water. You'll notice that it looks like the pencil is actually broken, okay? But it's not. All right, so I'm going to write out the equation here. N represents the index of refraction. It's equal to C divided by V, okay? And the value of C here, okay, is just the speed of light in air. So it's 3 times 10 to the 8 meters per second, okay? So it looks like this. So let's try this example here, okay? It says light travels through a liquid at 2.25 times 10 to the 8 meters per second. All right, so this is the value of V that's given. So I'm going to write it out here, times 10 to the 8 meters per second. And it's saying what is the index of the liquid, okay? So I'm looking for the value of N, okay? And again, the value of C is 3 times 10 to the 8 meters per second. All right, and what we're going to do is just plug it into this equation. So I'll put N equals C over V. Make sure you are always writing out the equation, okay, before you plug it in. So 3 times 10 to the 8. I'll put the units, okay, just so you can see the units canceling out. Divided by 2.25 times 10 to the 8, okay, meters per second. Okay, when you put in your calculator, I could just do 3 divided by 2.25. Okay, and the reason that you can do that, okay, is because the 10 to the power of 8 is just going to cancel out. Okay, and we're going to just round this value to 1.33. Okay, and this is basically what the index of the liquid is. So I'm just going to box it out. Okay, so that's our final answer. Okay, are there any questions there? So that looks good, okay? And again, make sure you're also practicing Snell's Law as well, okay? So let's try the next question here, okay? So what it's saying now, okay, so let's write it on the next page, okay? Is light is now traveling, okay, through air and encounters a second medium, and the second medium slows the light to a speed of 1.88 times 10 to the power of 8. Okay, so again, I'm going to put N equals C over V. This is a second medium. Okay, so it's going to be 1.88. Let me move it down. Sometimes 10 to the power of 8 meters per second. Okay, and I know the value of C in the air is 3 times 10 to the 8 meters per second. Okay, and again, what I'm going to do is just plug it into this formula I have. Okay, and we're basically just dividing, okay, these two values. Okay, and we're going to do divided by 1.88 times 10 to the power of 8. Okay, so you notice when I put the meters per second, okay, that the two values are just canceling out here. Okay, and the unit should cancel out, okay, when you're getting your final answer. So you could just do 3 divided by 1.88. Okay, and whenever you're rounding this, okay, the value of N, because this is the index of refraction, it basically tells you how much the ray of light is actually bending by. And you should always make sure that you're rounding it to 2 decimal places here. Okay, so I'm just going to box my answer here. Okay, and this is what the final answer is going to be. Okay, you can see that the equation is actually very simple. Okay, and I just need to apply the formula here and just plug in the values that are given to you. Okay, so with that, okay, let's try an example, okay, with Snell's Law here. Okay, and with Snell's Law, Okay, I have the equation, okay, for Snell's law. And I'm going to write it out here. So n1 sine theta 1 equals n2. Okay, let's put I actually instead, sine theta r, okay? The reason I'm writing I and r here is because the I actually represents the angle of incidence, whereas the r is going to represent theta r, represents the angle of reflection. Okay, so let's try a question here. It says, what is the index of refraction of a refractive medium? The angle of incidence, okay, in air. Okay, the angle of incidence is going to be given as 30 degrees. The angle of refraction is given as 15 degrees, okay? The value of N1, okay, for air is actually 1.00, okay? So I'll write air in brackets. So this is something you should memorize, okay? The index of refraction in water is 1.33. So all you're going to do is plug in these values here. So the N1 is 1. So you're doing 1 times sine 30 degrees equals, and I'm looking for the index of refraction. So we're looking for N2 times sine of theta r, which is 15 degrees. So just like this, okay? Does everyone see that? Because I'm looking for N2 here, on both sides, I'm just going to divide by sine of 15 degrees. Okay, and again, make sure you are showing your work here. The reason we're dividing it by sine of 15 degrees is so that it cancels out here, okay? And in your calculator, you're just going to put sine 30 divided by sine 15. Okay, and I noticed I'm getting 1.93. Okay, and this is basically what my index of refraction is going to be. Okay, make sure when it's N2, this is the index of refraction. Theta R is the angle of reflection. Okay. All right, are there any questions there? All right, that looks good. So I'm going to put example here. Okay, so with that, let's try one more example, okay, using Snell's law. So what is the index of refraction of a refractive medium? I'm given again, let's write this down. So I have the angle of incidence is given as 40 degrees. And the angle of refraction is 29 degrees, okay? So just like this. And the angle of incidence in air, okay? So one more time, the N1 is going to be 1. Okay, we're going to plug it into our formula. And one more time, make sure you are writing the formula out, okay? Before you plug any values inside. Because some teachers will take off a mark for that. Okay, so we're looking at our values here, okay? The angle of incidence is 40 degrees. So we're doing 1 times sine 40 equals, we're looking for N2. So actually we should just put N2 as a question mark here, okay? So I'm going to put N2 times, and the angle of refraction is 29 degrees. So times sine of 29 degrees, okay? And to get rid of the sine 29, we're just going to divide it by sine 29 on both sides. So just like this, okay? And as you can see, it does cancel out, okay? What I'm putting into my calculator is just going to be this whole fraction here, okay? So we're doing 1 times sine 40 and then divided by sine 29. Okay, and again, because this is the index of refraction, I'm rounding this to 2 decimal places. So I'm getting 1.33, okay? So my exact value here on my calculator, as you can see, is 1.325. I'm rounding it to 1.33, okay? And sometimes, let's just box it, sometimes the question will ask you to find what the index of refraction is and then identify the actual material, okay? Or the actual index or the medium that the light ray is actually going into, okay? So if you look at it in this case here, okay, this is equal to 1.33. This is actually the index of refraction for water, okay? So make sure you always just double check your answer here, okay? I have to make sure I'm getting the correct answer. Okay, so I'm just going to actually put it back in here into my calculator and just change this value, okay? So sine 40 divided by sine 29, okay? And in some calculators, you might have to actually plug in the value, okay? And just double check it, okay? And make sure that you're getting the correct answer here, all right? And also another thing is to make sure that your calculator is in the degrees mode, okay? And if it's not, make sure you do change it, all right? Okay, so that looks good. So today we covered basically the refraction, okay, and the actual formula for refraction, which is N equals C over V. Okay, remember C is going to be the speed of light. That's just like in air, so it's 3 times 10 to the 8 meters per second. Okay, and again, the question can also ask you not just to solve for the index of refraction, it can ask you to actually solve for the speed, okay, of the light ray in a different medium. We also covered Snell's law here. Make sure you are memorizing the formula. N1 and N2 are representing basically the actual index of refractions, okay? And the theta I represents the angle of incidence, and the theta R is going to be the angle of reflection, okay? And then you're just going to plug in your value here. Again, make sure you do just box your final answer, okay? That way you know that it is correct. All right? Okay, so that looks good. So thank you for watching this video. If you have any questions, please do let me know. And I hope you learned how to apply Snell's law as well as the law of refraction. And make sure you do like, share, and subscribe to the channel. And I'll see everyone next time. Thanks. Bye.